the Middle East and Gulf states. An average transatlantic flight burns between 50 and 60 tons of aviation fuel. The Times call for a greater fuel efficiency. How can this be achieved?
First of all, it's important to save as much fuel on ground as possible. To have a sequencing and timing that is more precise so aircrafts are not queuing on ground. When it comes to the departure phase, to have as short distance of flight out from an airport. When it comes to the cruise phase, we're already pretty much efficient today. We get the altitudes we need, but we need to have a bit shortened and more shortened tracks. But the most important part is to the approach and landing phases, where we are highly inefficient in many airports today, and we need to improve that very, very much.
Transatlantic flights play an important role in the modernization of the air traffic control system. At a meeting in Montreal, European researchers have recently presented the EU project designed to update air navigation called CESAR, which is entering its development phase with the establishment of the CESAR joint undertaking.
The CESAR project has two goals. The first, to carry out all the research and development and validation of the new technology, the new components, and the implementation of new procedures for air traffic control. The second is to update all the planning in Europe in terms of technology and advanced functional operations. What's new about the CESAR joint undertaking is the cooperation between the public and private sectors. This is the first time that we have cooperated in such a way to develop new technology in our industry.
Mapping out a new air traffic system is not only a technological issue, but a human issue.
I think one of the main problems in modernizing the air traffic control system is changing the mindset of those in the business. How we change the roles of the various actors, the air traffic controllers, the pilots, technicians, supervisors, and so on. A major difficulty is to ensure we move from a system that puts a lot of pressure on the human operator to a system that's much more automated, bolstering the work of the human by new, reliable technology.
Avec plus d'aide, plus de moyens fournis par des ordinateurs, de l'aider à travailler.
Likewise, the US have their own project to modernize air traffic systems. It's called NextGen, and the Montreal Forum focused on cooperation between NextGen and CESAR.
For many years, we've had a very close working relationship with Europe. I mean, going back 20 or 30 years ago, we've been working very closely with the Eurocontrol organization. Over the past recent years, we've engaged with the European Commission, and then even more recently with the CESAR joint undertaking, which has just recently stood up. At times, we're accused of moving too fast. You know, the Americans, we move out there and then we look back later. And at times, the Europeans are more deliberate, but typically we work towards a middle ground, and we've found that we have reached that commonality in most of these areas. And I think a good example of that type of harmonization is an initiative that was launched at the Paris Air Show last year called the Atlantic Interoperability Initiative to Reduce Emissions. I know that's a long word, but in reality that we call that AIR. But AIR is an initiative that's collaborative with government and industry and airline partners that allows us to test and run trials and demonstrations of the concepts of both NextGen and CESAR.
AIR is an initiative developed within the CESA framework. It consists of technical tests to establish new rules and improving the efficiency of transatlantic flights. SAS is one of the airlines involved in testing the system.
I can show you the track in. We're going to start after passing the border to Sweden, the descent. And we're going to fly a track that takes us into Stockholm Arlanda.
Scanner 7347, contact Copenhagen on 134.67.
On this route, it's not the shortest route, but it's going to be a rather short route and landing to the north. We're going to follow a profile which is the best one from efficiency and environmental point of view on the way into Arlanda.
Captain Storff is to demonstrate an actual green approach like those carried out within CESA. The green approach allows aircraft to save time and fuel by a direct descent into the destination from an optimum point with minimum engine power.
Right, start laptop on its right, it's time to turn it off as well. Now you can see the throttles throttling back. Descent, nav. Now you see we're down to fully idle thrust. 470-80 kilos per hour. In fuel consumption instead of 2,600, which we had on cruise. That's a major difference.
Tests run by SAS and Stockholm Airport have shown how aircraft approaches can be more efficient, less noisy for residents, and more comfortable for passengers. The red track shows a traditional approach, the yellow a continuous descent approach, performed without steps in the descent phase. The green one is an improvement on the continuous descent approach, and as can be seen, it's shorter. To allow the shortest approach, Sweden's air navigation service provider, the LVF Group, has tested for the first time in Europe the fourth dimension trajectory. The fourth dimension is the required time of arrival over the airport threshold, plus the 3 spatial dimensions. Arlanda, by implementing new technology and procedures, is meeting the targets of the CESA program. By 2020, every major airport will be doing the same. Our test with the SAS Airbus is coming into land.
50, 40, 30.
Spoilers.
We do have remaining fuel, 7.3 tons, and it was estimated from the beginning when we started in New York to be 4.8. So that's 2.5 tons total of saving.
Eurocontrol figures show that when a green approach will be implemented in 20% of Europe's airports, annual savings to airlines will be up to 120,000 tonnes of fuel and 400,000 tonnes of CO2 per year. And that's huge.